All right, hi guys. This is the notes for tangent lines for circles. So we have two theorems that we're going to use here. The first is that if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So basically here we have a tangent line. And again, remember we defined a tangent line as a line that intersects the circle at exactly one point. So if you have a tangent line, it's going to be perpendicular to the radius. So perpendicular means perpendicular lines are lines where they intersect, they form four right angles. So if the radius here is perpendicular to the tangent line, you're going to have a right angle. And thus on the diagram they have here, you're going to have a right triangle. And we just did a unit on right triangles. So we know a thing or two that we can use to solve different problems. Okay, the second thing we know is if two segments from the same exterior point, so we have a point out here, are tangent to the circle, then they are going to be congruent. So if we have two segments that are tangent here, or segments that are really part of tangent lines, right? These two lines here would intersect at one point. That means that those segments, we're going to say they're tangent to the circle, and we know they're going to be congruent. They're going to be the same length. All right, so if two lines are tangent and intersect at an exterior point, those two lines, or the segments, so the point of tangency to that exterior point, are going to be congruent. Okay, so this, they're just giving you kind of an example here. They're just saying it in words. But let's look at some example problems. Okay, some of the consequences. Okay, we know that rays MC and MZ are tangent to the circle, meaning they intersect the circle here at just one point, at point Z and point C. Okay, first thing, so we know first off that we have right angles here. These angles here are going to be right angles because the radius is going to be perpendicular to the tangent line. So number one here, they're asking us for the measure of angle BCM. Well, that's going to be 90 degrees, right? Because angle BCM is this angle here. And that first theorem up there told us that the tangent line is going to be perpendicular to the radius, so we're going to have a right angle, right? Number two demonstrates then the second theorem. So CM here is 5x minus 9. Right, and since you have two tangent lines meeting at an exterior point, those two segments, CM and ZM, are going to be congruent, so x plus 7. Right, those are going to be the same, so we can set them equal to each other. So 5x minus 9 is going to equal x plus 7. Right, and then we subtract x from both sides. That's going to be 4x on this side. You add 9 to both sides, you're going to end up with 16 on this side. Divide by 4, and we're going to get x equals 4. Okay. And then we can substitute that back in and find our length. So 4 plus 7 is going to equal 11. And then we can substitute in here. 5 times 4 is 20. 20 minus 9 is going to be 11. So in number 1 here, we use the first theorem that the tangent line is going to be perpendicular to the radius, so it's going to form a right angle. That's 90 degrees, angle BCM. And number 2, we're using the second theorem. You have two tangent lines that meet at an exterior point. So the two segments are going to be congruent. So MZ and CM are going to be congruent here because they're both parts of tangent lines that meet at an exterior point. All right, let's look now at number 3. Okay, number 3. 3 is saying the length of EM. Find the length of EM if CM is 12 and BC is 5. Okay. So again, one of the consequences of having the radius and the tangent line be perpendicular is that we have a right angle. So we have right triangles here. So triangle BCM BMC, right, is going to be a right triangle. So we have two sides of the right triangle. Let's find the third side. So that's the Pythagorean theorem, a squared plus b squared equals c squared. So we have 5 squared, right, our two legs, leg squared plus leg squared, so 5 squared plus 12 squared equals our hypotenuse squared, we'll call it x. Okay. 5 squared is 25. 12 squared is 144. Add those together, we get 169. So 169 equals x squared. You square root both sides to get rid of the square. So we square root, square root. We're going to end up with 13 equals x. Okay. So on our diagram here, this entire length here is going to be 13. We're looking for just this piece here in green, EM. Okay. We know the radius is 5. So we know BE was also going to be 5. Okay, and then we can find EM because 13 minus 5 is going to give us 8. All right, so we found the hypotenuse of the right triangle, which was 13. We know BE is 5 because it's a radius. So we know the radius is 5. Since BC is 5, we know the radius is 5. BE is also a radius, so we can make that 5. And then 13 minus 5 here is going to give us 8. So the length of EM is going to equal 8. Okay. Another way we could have done that, though, is we could have made this piece 5 and this piece x. And then when we did our Pythagorean theorem, we could have had 5 squared plus 12 squared equals x plus 5 squared. Okay. But then we would have ended up with, we have a quadratic, so then we would have ended up with 2 different answers. But we could have done it that way as well. Okay, we would have had a factor, and then one of the answers would be positive, one of the answers would have been negative. And then obviously the negative answer is not going to work because we have length, which is positive. Okay, so let's look at number 4. All right, the next one then, number 4. If the measure of angle CBM, that's this one here, is 60 degrees, and CM is 13 root 3. Okay, find the length of BC. Okay, so we didn't get a chance to talk about special right triangles, but we could use tangent here. So, right, we have an angle and a side, so we could use tangent. So tangent of 60 equals, all right, TOA, so it's opposite over adjacent, so 13 root 3 over x. Right, you'd multiply x on both sides. Right, and then you'd have x times tangent 60 equals 13 root 3. Right, and then you could divide tangent 60. Right, and then that's going to get you your answer, okay? You'd put that in the calculator and that'll get you an answer. Again, yeah, we didn't talk about special right triangles, but we kind of skipped over the part where you had 30, 60, 90 triangles and 45, 45, 90, and there's kind of shortcuts there where you don't actually have to use the trig, but we didn't go over that, so this is what we would do. Okay. Number 5 here. Find the length of CM if BC is 12 and BM is 20. So BM is 20. BC is 12. And we want to find CM. Okay, so again, we have two sides and we're trying to find a third. So that's the Pythagorean theorem, a squared plus b squared equals c squared. A and b are your two legs, so we're going to have 12 squared plus x squared equals 20 squared. So 144 plus x squared equals 400. Okay, that's going to leave you x squared equals 256. When you square both sides, you're going to get x equals plus or minus 16. But obviously, we can't use the negative, so it's going to be positive 16 because we have distance. Okay, and then the last one on here. Find the length of XE. Okay, if BM is 25 and ZM is 20. Okay, so basically XE is the diameter, so if we can find the radius, it's just going to be twice the radius. So if we find BZ here, which is a radius, we can just multiply it by 2 to get the diameter. So again, two sides, you want to find the third side, that's the Pythagorean theorem. So we're going to have 20 squared plus x squared equals 25 squared. That's 400 plus x squared equals 625 square. 625. So x squared is going to equal, you subtract 400 from both sides, that's going to be 225. And then when you take the square root of both sides, you're going to get x equals plus or minus 15. But since it's distance, we want a positive 15. So that means this distance here is 15. Right, that means that BE is 15 and XB is 15. So this total distance here, the diameter XE, is going to end up being 30. So our answer here is going to be 30. Okay, so those are the notes, and we'll also do a walkthrough going through the tangent assignment. Those are the notes, just two theorems and then some practice problems showing you how to use them.